Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 3.
Yang saya banggakan, Sobat Skapenta dimanapun kalian berada. Bersama saya, Elia Pinky Dini Hari, yang akan memandu jalannya acara launching perpustakaan digital Nishikoren Skapenta. Dengan semangat kemerdekaan, saya akan membacakan susunan acara pada pagi hari ini. Acara yang pertama adalah pembukaan. Acara yang kedua adalah sambutan-sambutan. Acara yang ketiga, launching aplikasi Nishikoren Skapenta. Acara yang keempat adalah demonstrasi penggunaan aplikasi Nishikoren Skapenta. Acara yang kelima adalah pengumuman new member.
Welcome to the Faculty of Engineering, Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta. Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta. Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people. To improve the Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Universitas Muhammadiyah Yogyakarta. Ya. Research and community service professionally. Universitas Muhammadiyah Yogyakarta. We are also a medium for students to develop an entrepreneurial spirit. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Certification, we develop students to become expert and Islamic critics, and we do research and community service professionally. We are also a medium for students to have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering Facility Universitas Muhammadiyah Yogyakarta. The lecture process. Universitas Muhammadiyah Yogyakarta, young and global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah atas berkat rahmat Allah Subhanahu wa taala dan didukung usaha keras dari seluruh sivitas akademika Teknik Elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi Teknik Elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari Laboratorium Telekomunikasi, Laboratorium Rangkaian Listrik, Laboratorium Digital dan Mikroprosesor, Laboratorium Elektronika, Laboratorium Instrumentasi dan Kendali, serta Laboratorium Komputasi dan Perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. And community service professionally. We are also a medium for students to develop an entrepreneurial spirit. have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas, di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah atas berkat rahmat Allah Subhanahu wa taala dan didukung usaha keras dari seluruh sivitas akademika Teknik Elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi Teknik Elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari Laboratorium Telekomunikasi, Laboratorium Rangkaian Listrik, Laboratorium Digital dan Mikroprosesor, Laboratorium Elektronika, Laboratorium Instrumentasi dan Kendali, serta Laboratorium Komputasi dan Perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people.
Tak sitok to ya akeh.
Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas, di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat.
Tes. Assalamualaikum. Apakah suara saya terdengar? Tes. Mas Ahdan, suara saya terdengar tidak ya? Your Excellency, the keynote speaker, Associate Prof. Dr. Khairul Anwar from Telkom University and Associate Prof. Dr. Saiful Jahari bin Hashim from University of Putra, Malaysia. Your Excellency, the Dean in Faculty of Engineering of Muhammadiyah Yogyakarta University, Associate Prof. Insinyur Aris Widyo Nugroho, PhD. Your Excellency, the Head of Department Electrical Engineering, Muhammadiyah Yogyakarta University, Associate Prof. Dr. Ramadhani Syahputra. The Honorable, the Chairperson of First International Conference on Electronic and Electrical Engineering and Intelligent System, or ICE3IS, and Second International Conference on Information Technology, Advanced Mechanical and Electrical Engineering, or ICITEMEE, Dr. Yesi Jusman. The Honorable, the Lecturer of Department Electrical Engineering, Muhammadiyah Yogyakarta University, Mr. Widyasmoro, ST MSc, as a moderator. The Honorable, all faculty members of the engineering and all the committee of ICE3IS and ICITAMEE 20 and 21, and all participants of webinar pre-conference today. Assalamualaikum warahmatullahi wabarakatuh. First of all, praise to be Allah Subhanahu wa Ta'ala, who has given us His mercy and blessing so we can meet in this room today in healthy condition and attend the webinar pre-conference of International Conference on Information Technology. Advanced Mechanical and Electrical Engineering, or ICITAMEE, and International Conference on Electronic and Electrical Engineering and Intelligent System, or ICE3IS 20 and 21 at Muhammadiyah Yogyakarta University. Secondly, salawat and salam may always be present to our Prophet Muhammad Sallallahu Alaihi Wasallam, who has brought us from darkness to the lightness. Ladies and gentlemen, on this wonderful day, please allow me to start our agenda today by reciting Bismillah together and continue for Tilawatil Quran. Bismillahirrahmanirrahim. The second agenda is singing the national anthem of Indonesia Raya and March Sang Surya. The third agenda is a welcoming speech from the chairperson of ICITAMEE and ICE3IS, Dr. Yesi Jusman. The floor is
Assalamualaikum warahmatullahi wabarakatuh. Good morning, all participants. How are you? I hope you all in healthy state today. It is a great pleasure for me to welcome all participants from several countries who join this webinar pre-conference of two international conferences, namely First International Conference on Electronic, Electrical Engineering and Intelligent System, ICE3IS, and Second International Conference on Information Technology, Advanced Mechanical and Electrical Engineering, ICITAMEE. First, I would like to thank to Allah God Almighty who give us opportunity to work until Sunday morning. And second, I would like to thank to Dean of Faculty Engineering, Associate Prof. Dr. Aris Widyo Nugroho, and I would like to thank to Head of Department Electrical Engineering, Associate Prof. Dr. Ramadoni Saputra. Next valuable things today is the webinar speech from Associate Prof. Dr. Khairul Anwar from Telkom University Indonesia and Associate Prof. Dr. Saiful Jahari bin Hashim from University Putra, Malaysia. Furthermore, I would like to thank to all participants of webinar for your effort and presence this event today. There is important thing that I want to tell today, especially for participants who registers the paper to ICITAMEE and ICEA3IS. Thank you for your patience because the review process that goes through is not only for the reviewing the content but also reviewing the formats. We also provide the guidance, like a guidance to several authors with a step conditionally accepted in order the two authors can improve the paper whose recommendation was rejected by the reviewer actually. Thank you for the attention. I hope you enjoy this webinar pre-conference. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Yesi Jusman, for the speech. The fourth agenda is the welcoming speech from the Dean of Department. The fourth agenda is the welcoming speech from the Head of Department of Electrical Engineering, Associate Prof. Dr. Ramadoni Syahputra.
Pardon, Mr. Doni. Your voice is not clear, so you must check your headphone, or you can unplug your headphone, because we can hear your voice clearly. No, no voice here.
Halo, cek.
Oh, cek. Ya.
Yeah, sorry. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah, Alhamdulillahirabbil alamin. Wassalatu wassalamu ala alihi washabbihi wa mawala. La haula wala quwwata illa billah. Wa basyiril ladzina amanu wa 'amilus sholihati anna lahum jannatin tajri min tahtihal anhar. Praise and thanks be to Allah Subhanahu wa Ta'ala, to God of the universe, for all the blessings that He've been given to us. Among this blessing are Iman, Islam, and health. Salawat and greetings to our Lord, the great Prophet Muhammad Sallallahu Alaihi Wasallam, whom we hope for Syafaat in Yaumul Akhir, the miracle in the last day. The Honorable of Associate Professor Dr. Khairul Anwar from Telkom University Indonesia. Nice to meet you again, Prof. Khairul, Dr. Khairul.
Thank you very much, Pak Ramadhani. So I am very happy to be here. Yeah, thank you very much.
Alhamdulillah. Thank you, Pak Khairul. The Honorable of Associate Professor Dr. Saiful Jahari bin Hashim from University Putra, Malaysia. The Honorable of the Dean of Engineering Faculty Universitas Muhammadiyah Yogyakarta, Dr. Aris Widyo Nugroho. The Honorable of Secretary of Electrical Engineering Department Universitas Muhammadiyah Yogyakarta. Also the Chairman of the two conference, Dr. J.C. Jusman. The Honorable of our colleagues in Electrical Engineering Universitas Muhammadiyah Yogyakarta, and all the happy webinar attendees. On behalf of the Department of Electrical Engineering Universitas Muhammadiyah Yogyakarta, we would like to express our deepest gratitude to Professor Khairul Anwar and Professor Saiful Jahari bin Hashim, who agreed to be a speaker today in a pre-conference webinar. In the first ICITAMEE and the second ICITAMEE. Attendees blessed by Allah Subhanahu wa Ta'ala. Since the beginning of 2020 until now, we are still in the period of the COVID-19 pandemic, and we still don't know how long this pandemic will last. One of the actual consequences of this pandemic is the acceleration of technology adoption in the electrical field, particularly, especially in telecommunication. Individuals are compelled to use digital tools for online meetings, online learning, and other purposes. Now that people understand and use effectively what are the Zoom meeting, Microsoft Teams, WebEx, and Google Meeting, people are increasingly realizing the critical role of the telecommunication network in interacting. As a result, economic face to challenge in terms of perfecting the existing technology in telecommunication. or developing new technologies that the community requires, the community needs in this part. This webinar is critical role, critical to us to get knowledge from two experts in electrical engineering, especially in telecommunication. Enjoy this webinar and stay healthy. Many thanks. May Allah subhanahu wa ta'ala be pleased with our activities. Nun wal qalami wa ma yasturun. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Associate Prof. Dr. Ramadhani Syaputra for the speech. The fifth agenda is a welcoming speech and opening ceremony from the Dean of Faculty of Engineering, Associate Prof. Insinyur Aris Widyonugroho, PhD. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirrahmanirrahim. Thank you. Good morning, ladies and gentlemen. It is great pleasure for me to welcome you to this webinar pre-conference event. I am very thankful to you, the honorable speakers, Associate Professor, Dr. Engineering Khairul Anwar, Director Center for Advanced Virus Technology, Telkom University, and Associate Professor Dr. Saiful Jahari bin Hasim, Department of Computer and Communication System Engineering, University Putra Malaysia, for taking time out of your busy schedule to attend this event. I also wish to thank the committees who have organized this wonderful event. Dr. Yesius Jusman, thank you so much for leading your team to create this webinar. I am especially honored to welcome the representative from IEEE Section Indonesia, partner universities, Head of Department Electrical Engineering University Muhammadiyah Yogyakarta, Associate Professor Dr. Ramadhani Syaputra, and also all participants. This webinar is held as a pre-conference of the first international conference on electronic and electrical engineering and intelligent system, or ICE3IS. This international conference has been initiated by Department of Electrical Engineering, Universitas Muhammadiyah Yogyakarta, which invited several partner universities to join in. And this conference will be conducted on 15 to 16 October 2021 in conjunction with International Conference on Information Technology, Advanced Material, and Electrical Engineering, or ICITAMEE, organized by Universitas Muhammadiyah Yogyakarta. Hoping this event may invite more teachers, industries, academicians to contribute in the next conference. I believe that the webinar provides an excellent opportunity for sharing knowledge in the field of smart and innovative technology for telecommunication technology in industrial era, especially in this pandemic. I have noticed that the aim of the webinar is to provide an environment for participants to discuss the development of smart and novel technology, particularly in the expertise of the honorable speakers. It will be interesting exchange of information, especially in terms of scientific development and other technological innovation. It is also expected that the webinar and the conference will create partnerships among universities and between universities and industries. I wish you all have a productive and fruitful discussion. On behalf of Engineering Faculty, Universitas Muhammadiyah Yogyakarta, I would like to apologize for any shortcoming that may happen during the entire event. Stay healthy, and we look forward to you in the first ICE3IS next couple months. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Associate Prof. Insinyur Aris Widyo Nugroho, PhD, for the speech. For documentation purpose, we will take some pictures. Please, all participants, open your camera. I will count 1 until 3. 1, 2, 3.
Again. Okay.
1, 2, 3.
Okay, I think it's enough.
Okay. Thank you for your attention all. Ladies and gentlemen, now we arrive at the core of the webinar, that speech of our two keynote speaker. It will be moderated by Mr. Widyas Moro, ST MSc. Let me introduce about Mr. Widyas Moro, ST MSc. Mr. Widyas Moro, born in Cilacap, Indonesia, on 5 November 1983. Employment in Muhammadiyah Yogyakarta University, Faculty of Engineering, Department of Electrical Engineering, and major in telecommunication. He had his bachelor degree in electrical engineering, Universitas Jenderal Sudirman, and then he had his Master of Science degree in Asia Universities, Taiwan. Mr. Widyas Moro also joined in Academic Forum Persatuan Insinyur Indonesia, or PIE. He has some research and published internationally. For moderator of the core session, the time is yours.
Thank you very much for Master of Ceremony to introduce me. Can you hear my voice?
Is clearly.
Yes. Okay. Thank you very much.
Yes, sir.
I would like to open and greet all of you here. Good morning. Very good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin wassalatu wassalamu ala Rasulillah sallallahu alaihi wasallam. It's pleasure for me to be here as a moderator in this webinar pre-conference. The Honorable the Dean of the Faculty of Engineering, Dr. Aris Wahyu Widyo Nugroho, the Honorable Chairman of the Department of Electrical Engineering, Dr. Ramadhani Saputra, and then the Honorable Chairman of the ICE3IS and Chairman also for ICITAMEE 2021, Dr. Yesi Jusman, and distinguished keynote speakers today, Professor Khairul Anwar. Good morning, Professor. Nice to meet you again.
Good morning,
And
sir.
also-
Assalamualaikum. Thank you very much.
Waalaikumsalam
Yes,
warahmatullahi.
and also distinguished keynote speaker for the second session, Professor Saiful Jari bin Hashim, that he will join us later on. And the distinguished for all the participants from Indonesia as well as from outside of Indonesia. Good morning, and we welcome you for this webinar pre-conference. Before we start with the first session of this seminar, I would like to give you some information and notes that we can pay attention, that maybe so that we can conduct the seminar and webinar in the smooth way. So in this webinar, we have two sessions. For each session, it will last for about 1 hour. So hopefully we can end this webinar for about 2 hours in total. In each session, it will be a presentation for about 35 minutes from the keynote speakers, and also followed by question and answer from the participant for about 20 to 25 minutes. During the webinar, if you have any question, so you can either just type in the chat room or in the chat feature of the Zoom at the bottom of the application, and we will read after the keynote speaker finish the presentation. Or even you can also use the raise hand feature for Zoom, that if you would like to have a question directly to the keynote speakers. So I think that one is important to be noted. If you have any further comment or question to the keynote speaker later on. So because we are limited by the time, so we directly go to the first session of this webinar pre-conference. Already with us here, Professor Khairul Anwar from Telkom University. Before he give or deliver his presentation, I would like to read his biography, short biography, because he has so long biography. Actually, if I read maybe 30 minutes to finish. I will not read all, but I just highlight some of his important points. Professor Khairul Anwar, Doctor Engineering. He was born in Kediri on August 22nd, 1978. Dr. Khairul Anwar graduated from Department of Electrical Engineering, Institut Teknologi Bandung in 2000 for his bachelor degree. He received master and doctor degree from Graduate School of Information Science, Nara Institute of Science and Technology, Japan in 2005 and 2008 respectively. Dr. Khairul Anwar was in University of Melbourne, Australia in 2007, University of Oulu, Finland in 2010, and Cranfield University, UK in 2018 as visiting professor. In September 2008, he was with the School of Information Science, Japan Advanced Institute of Science and Technology as assistant professor. Since September 2016, Dr. Anwar with the School of Electrical Engineering, Telkom University Bandung up to now. Is associate professor in Telkom University, and he served as a director of the Center for Advanced Wireless Technology at VTech 2016 to 2020. And currently he is the director of Center for Advanced Intelligent Communication, ACOMS, as one of the Indonesia University Center of Excellence supported by Ministry of Higher Education since July 2020. Dr. Anwar's technique is adopted by International Telecommunication Union, ITU, as a standard, especially in the multi-carrier based transmission technique and also multi-carrier based transmission technique for satellite system. Dr. Anwar is the chairman of Wireless Group Radio and Technology of Indonesia 5G Forum and also the chairman of Working Group of Service and Application in Asia Pacific Telecommunity Wireless Group start from 2016 to 2019. Currently, Dr. Anwar also served as Vice Chairman of Asia Pacific Telecommunity Wireless Group until 2020. Until 2022, sorry. Dr. Anwar received Best Student Award from IEEE Radio and Wireless Symposium, California, USA in 2006, Best Paper Award of Indonesian Student Association, Kyoto, Japan in 2007, Best Paper Presenter for Advanced Technology in International Conference on Sustainability for Human Security, Kyoto in 2011, Indonesian Diaspora Award for Innovation, Congress of Indonesia Diaspora, Los Angeles, USA in 2012, Ahmad Bakri Award 2014, and Anugerah Internationally Recognized Contribution for Governor of West Java, Indonesia in December 2016, National Achievement Award by UKP PIP Pancasila Jakarta, August 2017, and Best Paper Award in IEEE Tafjen 2018 Malaysia in July 2018. Dr. Anwar received TYATB Award 2019 of Indonesia Award-winning Inventor on August 2019 and consecutive as Best Lecturer from Telkom University from 2019 to 2020. His research interests are error correcting code, iterative decoding, coding for super dense network, information theory, signal processing for wireless communication, quantum communication, and error correction. He served as reviewer also for a number of main journal and conferences, in the area of wireless communication, coding theory, signal processing, and he is also the senior member of IEEE. For addition, he also has several patents. If I'm not mistaken, he has 8 international patents in the area of wireless communication, and also he wrote some books and chapter on books, on technical book and also others, and he got many grants from Indonesia as well as from international grants for research. For example, from Kominfo, from Dikti, from LPDP, and also for international grant from Japan Society for Promotion of Science and from Japan Advanced Institute of Science and Technology in Japan. So without waiting any longer, I would like to give some brief information about what he will deliver his presentation about. He will present about digital transformation and business. This talk provides in brief the trend of fifth telecommunication generation 5G and future generation 6G and beyond, where the quantum is the one of the candidate of 6G known as quantum K distribution for secure transmission. This talk then continued to the basic principle of digital transformation, explaining the 3-layer digitalization, and digital transformation. The basic principle of quantum bit also will be explained, followed by explanation of AI, artificial intelligence. And also this talk will elaborate the potential of AI and the quantum computing. So I would like to welcome Professor Khairul Anwar to deliver his presentation. Please, the time is yours.
Baik, oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, everybody. So first of all, I would like to thanks to Allah Subhanahu wa Taala, such that we can meet now in this very excellent meeting. So pre-conference of the ICE3IS and also the ICITAMEE of 2021. So I would like to thanks to the moderator, Pak Widi, for very long introduction about me. So I appreciate your time and your effort to do this. So to everybody, I'm very sorry if it takes time to introduce myself. But yeah, so it is actually, so I hope that it is also okay for you. And then I would like to thanks to also to Prof. Aris Widyo as the Dean of the in UMY or University of Muhammadiyah, Yogyakarta, and also the head of the associate professor in electrical engineering, Ramadhani Saputra. So this is a really very excellent meeting. Yeah, so I am very happy to meet you all here. And in the last, I would like also to thanks to Dr. Yesi Jusman for inviting me to give and also to share about how quantum meets artificial intelligence. So I do hope that this talk will be beneficial for everybody, will be beneficial for me, and also will be beneficial for Indonesia and also the science and technology. So I do hope that I can deliver my speech on schedule. So Pak Widyo, you give me the time for about 35 minutes, Pak.
Yes.
35 minutes or 45 minutes, Pak? So I have 36 slides. So I do hope that I can finish within 35 minutes. Okay, so thank you very much. So everybody, let's start my talk here. So I do hope that you can take note. Sorry, I should start from the first. you can take notes such that you can follow my talk. Okay, so I give the title the digital transformation and business when quantum meets artificial intelligence. Yeah, so I do hope that this is a good topic such that it can open the new ground of the science and technology. Yeah, such that everybody, we have a 97% here, yeah, can take the advantage of this topic. Yeah, such that you can follow up in your research. So my name is Khairul Anwar, and currently I am the director of the University Center of Excellence for Advanced Intelligent Communications. This is actually one reason why I should talk about the AI in this talk, because this should be the expertise of my laboratory in Telkom University in Bandung. And then currently I am also the vice chairman of the Asia Pacific Wireless Group, of which the office is in Bangkok in Thailand. And also, I am currently the chairman of technical and education activities in IEEE Indonesia sections, and I am also the senior member of the IEEE. So, following the topic of the conference, that is the Intelligent System for Sustainable Development. So, I do hope that this topic will make you satisfied with this meeting today. So. In total, I have been in Japan for about 14 years. After that, in September 2016, I returned back to Indonesia and joined the Telkom University as the associate professor. And I do hope that I can share my knowledge either in Japan or either in Indonesia after returning back to Indonesia. And everybody, so before I start my talk in detail, I would like to show the executive summary. So I know that maybe if you are very busy, if you cannot follow all of my talk, at least you can get some points, yeah, from my talk here, at least the 7. So the first, we have to make successful development and implementation of 5G, because 5G is the tools for digitizations. We have completed the research on 5G, but not yet completed for the implementation and also the business aspect of the 5G. And then we have the remaining business aspect of 5G, especially when we talk about Indonesia, because Indonesia is a very large country. But I think that it is also similar to your country, where the remaining business on 5G technologies are still huge. And then the third, this is actually the main of my talk today. Yeah, for the digital transformations, we have the 3 key enablers. The first is the quantum computing or quantum communications. The second is the artificial intelligence. And the third is the blockchain technology. So I do hope that I can make the good connection of those 3 key enablers. And then the number 4, yeah, that there are still many business applications of quantum technologies, especially when quantum meets artificial intelligence. So I do hope that I can explain how they can meet and how we can utilize. Yeah. And then after that, we may have a long-term investment in 6G, yeah, including the quantum artificial intelligence. I call the meat of the quantum and AI is the quantum artificial intelligence, and also the security for 6G and beyond. And then after that, we should also understand the philosophy of telecommunication, yeah, such that we can adapt the various chains. So I will talk about 7G, 6G, 7G, and also 8G, yeah, such that we can follow that in the market and also understand what a user need. And then finally, yeah, let us meet again in the ICE3IS and also ICITAMEE. Sorry, I forgot to put ICITAMEE here. ICITAMEE and also IEEE SOF 2020. This is the symposium on future telecommunication technology in December 2021. So this is the conference we had in Bandung. So I do hope that this is a good chance for us to meet each other, to share, and also to collaborate, inshallah. Okay, everybody, the next. this is the vision and mission of my laboratory, but I think that you can take some advantage, especially when I make the analogy of the telecommunications industry. So the tree has the root and also has the tree itself and also has the leaf and the fruits. So the root is the information theory, machine learning, fundamental research and signal processing and coding theory. But the fruits is the applications, a product or devices. So what we are doing in Bandung is 80%. We are working on the basics, on the fundamental of telecommunications, and 20% we are working on the applications of telecommunications. And then today I will talk about the quantum. So quantum is also another medium we are using to transmit informations, and we will combine with machine learning and also with information theory. So that's the analogy that I do hope that everybody can take some advantage here, and then you can know your positions. Where is your current research industry? Yeah. So okay, I go to the next. Okay. So everybody, the slide number 5. This is actually the main point I want to talk today. How can we make the connection between the telecommunication and digital transformation, and where is the position of the quantum and artificial intelligence? So this pyramid has 3 layers. So the first layer we call digitization. So digitization means that we convert from analog to digital, and we have the digital input devices. I think that you know this is the basic what we have now. For example, the scanner or everything, or the camera, that we can convert from analog to digital. And we have also the IoT and also cyber physical system. So for that we can convert from analog to digital. And then we have also the database and networks, or internal or external networks. So this for me, we can see that the first layer here, the basic layers, 2G, 3G, 4G, 5G, 6G, IoT, they are belonging to the first layer here, such that everybody can aggregate the data. And then after that, you have all the digital information, digital data. And then what is the next? The next is the data analysis. So after you have the digital data, you cannot stop, because if you don't make the processing, and then the data means nothing. So everybody, so there are 3 key enablers. So the first is the quantum computing, and then the second is the blockchain technology, and then after that we have also the artificial intelligence. So the quantum provides a very high speed and very excellent performance, especially in the speed of calculation and also the robustness. The robustness against some errors. Of course, I will also talk about what kind of error we have if we talk about the quantum communications. And then after that, here the blockchains. So with the blockchain technology, you can save money, because you can minimize also the process, such as the process is becoming easy when you make transaction. And then after that, artificial intelligence, it will help you to make a good decision, to make the good analysis. So when those 3 enablers, they meet together, and then you also have the, very strong cloud computing, and then you can save money a lot. And then the question is that what next? So the next is you have to make the digital business and operating model here. And then from the data you collected and you analyze, so you should use them for your digital business, and we call here the digital transformations, of which the target is the earning money. So this is the top target of the digital transformation, everybody. So digital transformation is not just from analog to digital, but the structure is like this. So this is what I want to highlight. And then what we should do now is that what is your contributions in the first layer, in the second layer, and in the third layer here? So in this talk, I would like to highlight the first and the second layer, because I am not from the business faculty. So I do hope that everybody who are coming from the business faculty, I think you can utilize your position and you can make the collaboration with us in the first or in the second layers. So in the second layers, as I said, that there are quantum and also AI and also blockchain. So here I saw the Gartner, the hype cycle. So Gartner say that all the technologies follows the 5 phase, 1, 2, 3, 4, 5. And then when you go forward, the x-axis, it is showing how mature the technology is, and the y-axis, it shows the how the people knows about the technology. So this is the y-axis. And quantum computing here is still low because not so many people knows this how powerful is quantum computing and quantum communications. So the Gartner put this is still in the first phase and also in the lower part. But artificial intelligence, because the application is very broad, so this is very famous. But they are still in the phase 2, and blockchains is almost going from the phase 2 to the phase 3. And but of course, this is still less famous compared to the artificial intelligence. So with this 3 understanding, I do hope that we can make some progress about the digital transformations, so that everybody can move forward all those 3 key enablers from the phase 1 into phase 2, into phase 3, into phase 4, into phase 5. Okay, so this is the second point I would like everybody to highlight. And then the third is this figure, everybody. So the x-axis, this is time, and this is the dashed line. This is the linear business development. So this is what does it means that if the conventional leaders, if the conventional leader or traditional leader does not believe with the power of the science and technology, and then the science and technology will evolve, such that following this exponential curve. So because of this, there will be the performance gap between the linear business and the business utilizing the current technology. So the question is that who will fill this performance gap? So I wrote here that unexploited business opportunities is frequently filled by the innovative, the startup companies that exploit the digital technology. So I invite the all startup, new company, startup or young generations to fill the gap between the exponential technology evolution with the linear business. So this is your chance. You will be successful in the future. Okay, so the next. So I will go to the first layer. The first layer is talking about the network, everybody. So we are currently here in 2020 and we have 5G. So in Indonesia, we just launched the 5G in June 2021. So I am really very happy with this launching, because I was thinking that the launching of 5G will be next year. But Alhamdulillah, this year we can launch the 5G in Indonesia. And then I am currently also helping the Ministry of Communication and Informatics to make the technical standard of 5G of Indonesia. And then inshallah, we will release another band for 5G in Indonesia, inshallah. So this is for 5G, and then the technology development of 5G, especially for the standard, has been completed. It means the remaining research on 5G will be on implementation and also the business aspect. So this is the reason of why starting from next year, we will reduce our portion of the 5G research into 6G. But actually, my laboratory has also started the research on 6G since 2019. So we also started this research since before 2020. And then in 5G, we have the technology based on the electromagnetic wave, where digital radio and software-defined radio is frequently used. And then what about the 6G and 7G? So we maybe use the photonic defined radio, but I think that it will be still using the traditional or classical communications we use in 5G. So we will be mixed between the electromagnetic and with electronic and photonic driven radio. But starting from after 6G, yeah, even though actually in 6G we will use the quantum key distributions, but maybe after that will be fully a quantum radio for 8G, between 7 and 8G. So this is the trend we discussed in the 6G summit in Finland 2019, 2 years ago. And then where is Indonesia? So Indonesia 2045, this will be the golden era of Indonesia. So I do believe that it will really happen. And at the time we will be between 7G and 8G. So I do hope that starting from 2021 here, yeah, 2021 here, that we can make new progress, yeah, such that we can prepare the golden era of Indonesia in 2045. So I think for everybody from outside of Indonesia, I think that you can also utilize this chart and map the target of your country. And what about the quantum radio, everybody? Especially for the quantum, not only quantum radio, but quantum technology in general. Yeah, especially in quantum computing. So this becoming famous in 2019, when the Google, yeah, at the time claimed the quantum machine they built called the Sycamore here. It did the task in 200 seconds, while the supercomputer, the conventional, the classical supercomputer need 10,000 years to perform for the same task. So although IBM at the time protest about this statement, yeah, IBM said that maybe not 10,000 years, but 3 or 4 days, yeah, to complete this task, while the quantum can complete within 200 seconds. Yeah. So starting from that achievement, the quantum is becoming famous today, yeah, especially for the computation and also the various applications. And the second reason is that the Turing machine, yeah, this is the x-axis, this is the bit, and y-axis, this is the resource or complexity, and also the performance here. So the quantum machine will surpass the Turing machine here at some point. I think currently has been did with the Google achievement with Sycamore. And currently we will have more number of quantum bit that we can build in the computers. So in that case, I think the quantum machine even have the higher curve compared to the Turing machine. Okay, so especially what is special from quantum information? So if everybody are from the physics department, yeah, so I'm sorry, what I talk here is only quantum information, not about the quantum mechanics. So in classics, we have the bit 0 or 1. So everybody please note here or, yeah, 0 or 1. 0, let's say that this is the number, and 1 is the, yeah, is the image, yeah, is the figure, yeah, numbers and also the figure. So 0 and 1. If, for example, if you have the 11 bits, so you have 111, 111, 00101. With the classical calculation, with the classical machine, what you can store is only one number, that is 2021 with this number. But when you are using quantum, yeah, so you have no longer classical bit 0 or 1, but you have the cat 0, this is here, and cat 1, not or, and here. So what you have, if you have 11 quantum bits, is that you have all possible numbers. Yeah, you store all possible numbers from 0 to 2047. So the same register, so we call here the 11 qubit register, and this is 11 bits, but you store more numbers. So this is what makes the quantum has the faster and has the powerful machine, is a powerful machine. And then the second benefit of the quantum is about the scaling and also the complexity, but especially when we perform the calculation here. In classic communication or classic machine, you have if you want to add 00 plus 01, yeah, you have 1 here in decimal number. But if you add 01 plus 01, so you have 10 here. So you have 1 equal to 2, and then mod 2 becomes 0 again. So you need the 2 steps, yeah, 2 steps in the classical system. But in quantum, for example, if you want to add perform this summation, you need 1 step only, because 1 step they can save the result and also the carry, the carry of the summation. So in quantum, you can make a faster and more efficient computations. And then if you have the 300 quantum bits, you can store all numbers here. It's where this number is larger than the numbers of atoms in the universe, even though you have only 300 quantum bit. And then I also make note here, that this is the list of the current quantum computer by August 2020. That currently we have 5,000 qubits. So you can, you can see that this is just, even though just 300, you can store all numbers here. But what happens if you can have the 5,000 qubits? So you can store more. Yeah. So this is a very powerful quantum machine currently, in August 2020. And when I talk about 200 seconds, that is the Google claim with the Sycamore. Even though with 54 qubit, they can generate prime numbers, typical prime numbers that within 200 seconds here, even though 54. What happens if you have a larger quantum bit? So this is actually the current progress in the world about the quantum computing. And then I would like also to show what is the picture of that quantum machine. So this is in 2016, the Google make the product of the 9 qubit, with this trap ion. So there are many possible way to make the quantum computer, everybody. And this is in this year, Google make the trap ion version of the quantum. And then Intel, this is in 2017, they create the 17 with another way of quantum machine using superconducting qubit chip. And then this is IBM in 2017 developed the 50 qubit using trap ion machine. And in 2018, Google developed again 72 qubit called the Bristol cone. So after that, followed by China and also several countries, including the India. So India also, the Ministry of India also have the decision that they develop the quantum technology beside their fisheries product. This is what I hear from the news about the India, how they make the almost half of the budget for quantum, and the other half, this is for fisheries. Okay, so since the talk is about the quantum meets artificial intelligence, so let's me talk also in short, in brief, about the AI. So everybody, actually AI and the information theory, and I do believe that you are also working with information theory, or at least you study information theory when you are studying about the communication system. So information theory and machine learning, so they are two sides of the same coin. AI and information theory are almost the same. So you can also understand how the error, you can use the entropy to check the error in the AI, in the learning process. So in 1960, cybernetics was populated by information theorists and computer scientists and also neuroscientists. And the state of the art of algorithm for data compressions and error correcting code use the same tools as the machine learning. That's why for everybody who are working on information theory, I think it is will be very easy for you to move to AI, to move to AI, because the tools are the same. And then after that, the challenge in engineering is that the engineers, many researchers would like to create the machine that can learn and perform pattern recognition or discover pattern in the data. This is why I put I talk about the second layer of the digital transformations, because we need this to analyze the data. And then this is the very basic part of the AI, everybody. So you have the activation of the neuron, that is A equal the summation of the WI, XI, where W is the weight of the input, that is the input data is X1 until XI. The W0, this is for bias adjustment, where WA here can be many numbers for until from 1 until A in this figure. And then the output is Y here, and Y is also the function of A, and A is the summation of here. And then what you should minimize is the error, that is T. So T minus Y should be close to 0. That is actually the main idea or the philosophy of the artificial intelligence. So here the target T should be as similar as possible as Y. And then let's show some very basic of the AI, because I need to explain this such that I can make connection with the quantum. So you have the Y here as the function of X and W. And then this is actually a very simple example when you make the decision of a BPSK, for example. So when you put a sigmoid function here, this is a logistic function, also very famous, and that is the 1 divided by 1 plus exponent minus W1 x1 plus W2 x2, where you put x2 is between minus 10 and 10, and x1 minus 10 and 10. And your weighting factor here is 0 and 2, so you have this curve. So you can, with this, you can make decision either when the input next time belongs to this, and you can decide that the Y is here, and otherwise the Y is minus, or the Y is 0. So this is actually very important in telecommunications to make decision and also to make error correction inherent in the artificial intelligence. Okay, so by doing that, I would like to show how the improvement of the deep learning, the TL here, deep learning in polar decoding, used in 5G. So everybody, 5G is using the polar decoding, and then there are many ways of performing decoding of the polar, because it is not for the receiver. You don't need to follow exactly as in 3GPP. But 3GPP only make the standard of the transmitter. For the transmitter, you should follow exactly. But for the decoding, it is up to you. Either you are using deep learning, you are using conventional decoding, it is up to you. So this curve is using the conventional belief propagation in polar decoding. So the performance is very bad. And when you are using the successive list decoding, here you successive list decoding 32, it means that you make the 32 paths in the tree. Of course, this will be the best because of you follow the all possible pattern and then you select the best among them. But if you are not using the SCL32, but if you are using machine learning, for example, this red and also green, they are using machine learning. So you can have the better performance compared to the conventional decoding. So this is another benefit of the machine learning, even though you don't need to do the successive cancellation or belief propagation. But with the training, you can have the better performance in the faster way. So this is another benefit of the artificial intelligence in the decoding of the current wireless communications. And then in the slides, let me explain when the quantum meet artificial intelligence. So everybody, I use this. Oh, sorry, I forgot to put this is from Google. So everybody can find this figure in Google. Yes, I should put here to credit from Google. AI is here. So AI is performed in the classic domain, classical domain. So indicated by the two lines. So in the quantum structure, two lines mean classical bit, but one line mean the quantum bit. Yeah. So when quantum meet artificial intelligence, then you can perform very fast, even though the data is very large. And then the AI will make the decision and evaluate the cost and function, and then give the input again to adjust the quantum model here. This is the quantum data set. So to make this, I think everybody should understand how the quantum work and how you can convert from the classical bit into the quantum bit, and after that the quantum model here, and then after that measurement here. So there are at least there are three kinds of measurement, but in this slide I would like to show that only two kinds of measurement. So the first is measurement postulate. So this is the PM. M is the number of bit you want to measure, and this is the bra. This we call bra psi, and MM is the gate, or the gate or the operator MM to measure the bit number M. Star mean the complex conjugate, and MM is we should use this, and then to the targeted bit, and then this is cat psi. By performing this, you can have the probability of having the classical bit here. And then the post measurement state is the psi cat psi prime, and then that is the ratio between the MM and cat psi divided by what you obtain from here, from the measurement postulate. So by doing this, everybody can obtain the classical bit, and then from the classical bit you can move again to the quantum process. The application here, the application of this is, I think this is very, very important in the future. That is the drug discovery, and then the data encryption. Drug discovery, I think this is very useful currently, even though in COVID-19 we need the efficient drug, and then after that the data encryption, and then the big data. So big data, I think this is matched with the quantum power, and then also for another application, this is for the logistic. And then here I want to highlight the importance of the measurement here. So quantum without measurement, this is I can say that maybe it is useless if you don't do measurement. So always you have to have this measurement here, and I think in the ITU, this will be standardized how to measure and what is the unit of the quantum in the future. So in this slide, everybody, I do hope that you can understand actually what is the quantum and how we perform that. So I will show here the famous phenomena, this what we call the Schrödinger cat, because the Schrödinger at the time, he talked about the quantum technique or the quantum theory. So he make the assumptions when you have the cat in the box, and then the box has the radioactive material that has the probability of 0.5, of decay and not decay per hour. So when and then after that you have here the Geiger counter. So when this counter detect the particle, and then the Geiger counter will initiate the hammer here to break the cyanide poison. So then this poison will make the cat will still alive or die. So this is the question of the Erwin Schrödinger at the time, how the quantum explain this phenomena, because according to Schrödinger, that the cat cannot be in the state of life and dead at the same time. And then and then after that many people is trying to explain this phenomena, and actually I am also trying to explain to you with this quantum circuit with the 3 qubit here. So everybody, let's say that you have the qubit Q0. Q0 is can be alpha ket 0 plus beta ket 1. Alpha here can be 0.5 because this atom can decay with the 0.5 probability. 0 mean not decay, and 1 mean decay, let's say like that. So this Q0 can be decay or not decay. And then after that, Q1, Q1, this is the poison of this cyanide poison. Yeah, this 0 mean not break, and 1 mean break. Yeah, and then sorry, here
Sorry, Professor.
Yes,
your time is
limited.
Yeah, maybe 5 minutes more.
Okay, yes, I will try to
you,
complete within 5 minutes.
I'm sorry.
Yeah, no problem. Yes, and then the Q1, this is about the poison here, and the Q2, this is the cat. This is still live or dead. Yeah. For example, let's say that a life is 1 and then dead is 0. So by performing here, everybody can also either check the C node. This we call the C node gate. Yeah. Or you can make the matrix multiplication. Actually, it's very easy to prove that you have the at a measurement here. You have the psi. You have psi containing alpha 001. 001 means that atom is not decaying and poison is not released, and 1, yes, it means that cat still alive. B is atom decays and poison released, and the cat dead. Yeah. So the state in here is the alpha cat 001 plus beta cat 110. Let's say that alpha is 0.5, like here. So this you have a half life and half dead. But actually, that is not the case, because when you do not open the box and you don't know exactly what happens. But when you open the box, it means that you do measuring. Yeah, when you open the box, and then you will understand either 001 or 110, what you can have here. So this is what the quantum, how the quantum works, everybody. And then this is another measurement that we perform. So we propose the stabilizer here containing the kit ZXX. We submit in IEEE APCC 2021. We will make presentation inshallah, and we propose this quantum, and we prove that we can make the smallest perfect quantum accumulate code, and we also evaluate the performance and the theory, and alhamdulillah they match, exactly, almost exactly for the qubit 2 here. Sorry, for the error correction code, and this is without error correction, and this is with error correction, and the error is like this. So there are 3 kinds of error: Pauli X, Pauli Z, and also Pauli Y. And then alhamdulillah we can make the design of the smallest perfect quantum codes, and then we expect that we can increase this for the future applications. Okay, so because my time is limited, and okay, we just want to share here that our laboratory in Telecom University has member, and our member has completed the quantum bronze during the International Quantum Summer School in July until August 2021, and alhamdulillah, I myself also has passed the quantum silver, studying about this topic. And then because time is limited, so I try to explain business, because this is also in my title. So everybody, yes. Everybody, this is the business application of quantum technology. So currently, who is buying the quantum computing is the military and also secret services, because of the SOR algorithm. It can break the RSA code within a second, while the conventional computer needs 10 years, 10,000 years, sorry, 10,000 years to break the RSA code, but quantum can break within only a second. Within, sorry, not a second, within several seconds. And then how it works, because for example, like this, you have the message, let's say that hello, and then you encode into 2, and then you have use the public encryptions. So you put the 514 means that 2 power of 5, and then you make the modulo 15 here, and then you have 4, right? And then 4 is the encrypted message you transmit to the receiver, and the receivers must use the private key. Private key is 1114. yeah, such that you can return back to obtain 2 here. But quantum with SOR algorithm can obtain this 11, 14 even just from here. So that's why the military the military in America and also in some countries, they bought the quantum computing because they want to keep the information secret, but they can open information of others. Yeah, so this is the current business in quantum for security, and then also for Grover search algorithm. This is for large and unstructured database. This is important for artificial intelligence. So the quantum AI, I think everybody can start from this database from Grover search algorithm, and then quantum can also be used to solve the linear equation, especially when you have very complete and very complex linear equation. You can use the quantum computing with quantum algorithm to solve using the, for example, HHL algorithm. And then the most famous currently is the quantum approximate optimization algorithm. It can be used to optimize any kind of technology. Yeah. So this is still measurement. So optimization, you input again to the quantum domain here. And then the application is, for example, for the traffic planning. So Volkswagen is using this one. And also BMW is using the quantum for the optimizing the robot and production line. And also the Daimler also use this to explore the application of material science. And this is the NASA is using this to optimize the aeronautic Earth and space exploration missions. And then Airbus, they're using quantum computing for airflow modeling aircraft wing. Yeah, so of course this is not the result. This is just imagination, everybody. I think the result is not published. And then we can use quantum for many applications. For example, quantum machine learning, they may speed the discovery of the COVID-19, the treatment. This is used for the biology and also medical treatment, and this is used for material engineering. This is done by the Japanese industry, Mitsubishi Chemical and IBM. They make the quantum computing to model the molecular dynamic in lithium air batteries. And then also in the finance and banking, you can make the portfolio optimization, pricing of financial instrument. And also for the electronic, of course, because this is from electrical engineering, everybody. So you can make also optimization based on the quantum. And then for the energy, it is ExxonMobil is also using the IPMQ network to explore the practical application of science and business. And then I think because my time is up, and I do hope that I can discuss with you later about the future applications of the quantum technology, inshallah. Okay, so thank you very much. Let's have the good discussion. Thank you very much, Pak Widi, and I close my presentation. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi
wabarakatuh.
Thank you very much, Professor Khairul Anwar, for his very interesting and very nice presentation, even though still have some slide that hasn't been presented, but it's okay. I think we can continue with some question and answer session. Please, if all participants, if any one of you want to ask to Professor Khairul Anwar about his topic, you can raise your hand in the application, just in the bottom of your application, or you can use a chat feature also. Any question? We have about 10 minutes for question and answer session. Okay, so Pak Khairul, to open the discussion. So far in Indonesia, how is the research going? In theoretical or already maybe have planned to be implemented in the near future in your lab or maybe with the government? Because I know that you have really have good communication with Kominfo. So how far you can, share this knowledge to be implemented, so we are not lag behind of the technology.
Yeah. Okay. Thank you very much, Pak Wiji. I think this is very, very good questions. So yeah, my answers are twofold. Yeah, the first is we currently are joining and we are collaborating with the international partner such that we join this quantum world summer school in 2021, and alhamdulillah we passed the examinations. So in this collaborations, we use the Anaconda Navigator and also quantum Python programming to program the quantum simulation and also our idea. So with this, we can use the international computer, and then we currently what we have developed is the algorithm. So, but we need a proof, so that we need the international computer, because if the number of qubit more than 13, I think current laptop cannot make the simulation for massive simulation of the communications. So currently we are developing a quantum error correction code, Pak, with 13 qubit. With 13, even just 13 qubit, the computer of my student is suddenly, sorry sir, this is out of memory. Even just 13 qubit. So I think this is because we simulate the quantum on top of the classic. So the classic cannot manage all. So this makes the memory, it's not enough.
So you need to buy a quantum computer.
But that will be very expensive, Pak. So what we are doing is we collaborate with international, and then we use their computer. So I think in the quantum summer school we use sorry, where is my I think we use this one. I think we use IBM. We use IBM simulator. So we use IBM Cascade simulator here, so it can manage until 30 qubit. But actually what we are doing is still 13 qubit, because we are proposing a new coding quantum error correction code with 13 qubit. But alhamdulillah, just this week we can reduce into 12 qubit. Even though with 12 qubit we have the performance like in the 13 qubit. Yeah. So this is the point one. So we are collaborating internationally. And then the second, we just propose collaboration with Kominfo, as you said, that I am proposing to Kominfo that I think Indonesia should develop the quantum, especially quantum satellite, like what the British is doing in this British Telecom. So this will be the new era for the satellite, because the satellite is no longer transmitting the classical communication, but also transmit the modern communication with a quantum. So by doing this, I think the position or the importance of the satellite will be increasing with the quantum. Why we did the satellite, quantum satellite? Because to make the secure communications, we cannot rely on the fiber optic, because quantum is currently using photon. So it means that you use laser here to communicate between satellite and the ground station on Earth. So if you are using the fiber optic, maximum fiber optic can reach 600 kilometers. You cannot have more than that. Even though in UK last month they can maximum 630 or 650 kilometers, but more than that you cannot do with the fiber optic. So so researchers in the world use the satellite, and then Chinese is also making the advanced achievement in quantum satellites here. So they make the quantum satellite and set up the secure communication with a distance of 1,200 kilometers here, and they make preparation for about 13 years. Yeah, 13 years since 2020. Since 2002. Since 2002, they start working on quantum, and then 2017 they launch satellite with quantum devices. So I try to promote this to Indonesian government, that I think Indonesia should do, even though not the same as what China is doing, but we should use quantum, starting from this year, I think. Yeah, so I will try also help our government with first making the experiment on Earth first, on Earth, and then after that, if it is successful, and then we make on hubs or on drone, and then after it is successful, and then we send together with the satellites. So maybe I can also make cooperation with Telkom satellite, because we are in the same group of the Telkom. So that is my dream in the future. Okay, so I hope that it answered your question. Yeah.
Thank you so much. Yes. So it's a very good projection to the future that you already plan step by step to realize the quantum technique for Indonesia. It's very good.
Thank you,
and
please pray also
we
for
are
us.
happy to hear that as Indonesian.
Thank you.
We have implement the newest technology. Okay, so because our time is very limited, so I think we should end the question and answer session here. Thank you very much for Professor Khairul Anwar for delivering your presentation. Very insightful, and hopefully we can have another collaboration and another cooperation in the future. Thank you so much.
Yeah. Thank you very much.
Thank you so
and
much.
Thank you very much, everybody. Yeah, I'm very sorry if I have mistakes, but I am very welcome for any opinion and also comment from everybody. So thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Once again, thank you very much for Professor Khairul Anwar for delivering his presentation and also answering our question from the participant. And now we are going for the second session. Already with us, Professor Saiful Jahri bin Hashim. Good morning, Professor. Maybe already join us, Professor.
Hello, Assalamualaikum.
Saiful. Waalaikumsalam, Professor Saiful. How are you?
Yeah, thanks. How are you? I haven't seen for a long time.
Yeah. I'm sorry, because also you cannot join in the early of this webinar, so we put you in the second session. So
okay.
Are you ready, Professor?
I'm trying to share my slide. I'm not sure whether you can you see my slide?
Okay, not yet. Maybe Adan, can you help Professor Saiful? Okay, so before we continue with the presentation from Professor Saiful, I will briefly introduce Professor Saiful Jahri bin Hashim from University Putra, Malaysia. Professor Saiful Jahri bin Hashim currently is Associate Professor in the Department of Computer and Communication System Engineering, Faculty of Engineering, University Putra, Malaysia. He received his PhD from Cardiff University in UK 2011, Master of Science from National University of Malaysia in 2003, and Bachelor of Engineering from University of Birmingham, UK in 1998 in the field of electrical and electronic engineering. He is one of the winners of the prestigious IEEE MTT 11 2008 Creativity and Originality in Microwave Measurement Competition. His research interests are cloud computing, Internet of Things, network security, non-linear wireless measurement system, and I think IC design maybe, right? He is also has contributed for more than 100 more than 100 technical and research publication. So yeah, I cannot read all of your CV, Prof, because of the time. So we just directly pass the time for you, for Professor Saiful to deliver your presentation. Please, Professor.
All right. Have you seen my presentation? Can you see it or no?
Not yet, Professor.
Okay. Okay, can you see now?
Yes, yes.
You see now, all right.
Yes.
All right. Assalamualaikum and very good. I think morning now, afternoon in English. All right. Okay. First, thanks for for inviting me for this conference. Okay. Right. I hope I'll be, if not without COVID, maybe inshallah we'll be there. Just before COVID, I think I went to, I went to Sumatra, Bukit Tinggi, just before the COVID. But so maybe next time you can can come to
of course,
university.
you're welcome to Yogyakarta.
Yeah.
Next time, yes.
All right. Okay. Okay. Now, I think I want to share with you our research and our work on LP1. LP1 is low power wireless area network. Okay. Here we're going to share with you the state of the art. That means what is currently available in the low power wireless area network technology, and what is the current trend and future direction. Okay. As mentioned by Mr. Vidyas Moro, I'm from Institut Putra Malaysia and lecturer there for about 20 years now. Okay, more or less, and yeah, I think it's a pleasure to present to you all. All right. Okay. This is the content. What we are going to see is the introduction and to the low power wireless area network, and then we're going to see the performance characteristic and what are the factors affecting the performance, and then we're going to see what is the existing technology for LP1, and next we're going to cover the upcoming, the latest LP1. One of them is our work, and then the future direction. Okay. All right. Okay. As mentioned by the chairman, actually I'm in the field of Internet of Things, IoT. Okay. To be honest with you, the IoT is actually the combination of of many technologies. So IoT means Internet of Things. That means it used to be people are connected, right? You connect the your phone and you talk to your to your family and so on. But now and in the near future, we're going to have more things rather than phone. Okay, for example, now we probably have a 10 billion phone, which is about double the amount of human, right? I mean, for example, maybe 7. So maybe more than half people have handphone now, and then the phone numbers is about 10 billion. But in the near future, the number of things will be maybe, I don't know, maybe 10 times, 100 times, 1,000 times, billion times more than the phone. So that means your watch going to be connected. We have a smart watch now, and then your refrigerator, maybe they'll be connected as well. And obviously your house. Okay, I'm not sure in Indonesia, but in Malaysia, our meter, my house meter, they just changed, this year, so that this meter for the power supply, okay, is connected to the internet. So because of the pandemic, because of the COVID, people cannot come to check your meters, right? So now if we have this internet or IoT enabled power meter, so they can just read the reading from remote from the HQ, and then they can send you bill at the end of the month. So it's quite handy that way, right? Okay. So what is what is the IoT solution? here for the architecture, as you can see, you have mainly 4 stage. You have a sensor actuator, and you have internet gateway or data acquisition system, and you have the edge IT, or sometimes people call it edge computing, right? And then you have the data center to the cloud, So as you can see, this, this divided, the edge is divided into the left-hand side and the right-hand side. The left-hand side normally on the customer side, or on the factory, inside the factories or inside the house, and then the edge normally belong to the internet service provider and so on. Okay, the edge is basically the what you call it, closer to the house or customer premise. Okay, as I mentioned to you, actually this thing, actually the everything in the world, actually they are analog. The reason we have this analog to digital converter and so on, and digital to analog, is because the world now having actually doing in the digital, having process in the digital world. So that's why you have this analog to device data acquisition and so on. Okay, and obviously the sensor actuator can be wired and wireless, and then because of the convenience of wireless, most of the sensor now they are connected wirelessly. Basically there is no wires. Okay, so it is very convenient. You can go mobile just like your phone, right? So you don't need to attach to your to your house, right? You can, it's become portable and mobile. For example, now if you buy a new car now, most likely your car have a network connection, 4G or internet connection. So you can just put your SIM card, and then your car going to be connected, to the internet. Okay, so it's kind of something like that. Or you don't need your phone. Actually, the car comes with its own transceiver, right? A transmitter and receiver. Okay, just one important thing that you need to understand now. It used to be we call it wireless sensor network, but because of the way of the Internet of Things, okay, actually it is kind of generalized the wireless sensor network. So actually, if you want to include the wireless sensor and actuator network now, so because this is, I think because of the very long name, they just call Internet of Things. So actually you have this wired, wireless, and sensor and actuator. Actually, sensor is how to sense back data to the cloud, and then actuator is how to control back. For example, if you have an Internet of Things system for your farm or for your small garden in front of your house, right? A lot of people during COVID they start gardening, right? Similar to me, right? I start gardening and grow my own vegetable, like I don't know. Like you, maybe the popular one is bayam, spinach, kangkong. So you can grow your own, and and it's organic, and is, and you can for free, right? You don't need to you just buy the seed and it's grow. But let's say you want to control your garden, then you probably need your your sensor to for example to know whether the water is enough, or there is not enough water. So you're going to sense, and then you use the actuator, for example, to open the valve to water your vegetable or your garden, right? So this is a two-way process, where that's why you have this sensor, and actuator inside here. Okay, all right. Next. Okay, before we go to this low power wireless area network LP1, I want to give you the overview, right? The overview. What is the landscape for wireless, especially, right? Okay, because we are focusing on low power wireless, so we're not going to talk on wired. Okay, we're going to mostly focus on wireless. So you have this proximity, which is your NFC and RFID. For NFC, you have to touch your phone or your smart card, and for RFID, maybe you can. It's not like in proximity. Probably you have like about 10 meters, 20 meters. Okay, I think Indonesia, I think yesterday, if not mistaken, they just announced the potential of toll for highway. Indonesia just announced gatless RFID toll gateway. Okay, for Malaysia we already implemented, but it's still we have the barrier or gate. I think Indonesia, I think yesterday they just announced going to be wireless, so you don't need this gate, because gate actually is very slow. I think the proposal for Indonesia, I think is much better than Malaysia, because Malaysia we still have a gate, so that slower the traffic. I think in Indonesia you cannot do it. You have you know, a lot of vehicles, and I don't know what they call it in Indonesia, macet, right? You have a lot of traffic traffic jam or macet. Is it correct?
Yeah, okay.
Yeah,
Yes,
macet.
macet.
Yeah, so it is in Malaysia we call it traffic jam, you know, not macet. So we have a lot of traffic jam in Malaysia. So I think RFID is very good. So apart in addition to RFID, you have a wireless personal area network. This is going to be very popular if you have a smartwatch, you know. And then personally, I'm developing some RFID device and solution, and IP1 as well. IP1 normally for smartwatch or for your healthcare device, ECG, and you know, and you know, for your heart monitoring and so on. Okay, and Bluetooth included into this one. I mean, if you buy earphone now, most likely your earphone doesn't have doesn't have wire, so your earphone, Bluetooth earphone connected to, you know, there are many. You have Bluetooth, Zigbee, Z-Wave, you know, wireless and so on. And then you have this wireless local area network. Now I'm connecting to you through my house Wi-Fi, you know, or wireless, fidelity, what is short form for wireless Wi-Fi or wireless local area network. Okay, and then my phone is connected to the wireless area network or neighborhood, whatever they call it, or wireless. Sometimes they call it wireless WAN area network. So this is kind of your 4G and 3G, 4G, and your 5G here. I'm not sure about it in Indonesia, but in Malaysia, the 5G has not yet been rolled out. But mainly we have this 3G or 4G, in this part. Okay, we call it cellular because cellular is, you know, cell-based. That's how they connected to the internet service provider, right? Okay, so and then beyond that, you know, the long range one, wireless wide area network. You have a newcomers, okay? In English we call it new kids, on the block, right? So you have this LoRa, which is very popular around long range. LoRa stands for long range wireless. Sigfox, Zalensa, PGC, and so on. So, but the LoRa is by far is the most popular one. We're going to focus more on LoRa and the gang for today. And then you have to understand that this is a new technology. It's only partly implemented in 4G and maybe going to be more in 5G. Even 5G now, they don't have this low power wide area support, to be honest with you, inside the standard. Actually, yeah, they're proposing a new standard, but the current standard now is not that low power. They call it what they call it NB-LAT and so on. But we're going to see about that later. Okay, so okay. I just give you this what you call it, this kind of graph positioning, right? If you want to do research, for example, I think it's good to have this this kind of graph. Okay, in this case, if you want to do LP1 research, you're going to see where's your position. Okay, for example, here in our case, we have a power efficiency and the range. Okay, actually you can put another become a 3D, for example, bandwidth here. But anyway, I just give you this 2D kind of graph. So in this case, as you can see, your Wi-Fi is here, right? So the Wi-Fi is not power efficient. You know, it probably need few watt of, it's just basically your gateway is basically a router gateway is basically a PC. So you need a few watt, of device, right? So Wi-Fi is run here. It's not that power efficient. And then on the scale, you have a Bluetooth and BLE. Actually, BLE is embedded inside the Bluetooth technology. Bluetooth 4, they have BLE. Bluetooth 5, they have BLE. Actually, is a low power version of Bluetooth. All right. How everybody know Bluetooth, right? I think if you have phone, you know there is a Bluetooth that whether you use it or not, but they are actually by default is included inside your phone and PC. And then you have the Zigbee wireless. That's not very popular. And then you have this LTE, which is your 4G. LTE is just another name for 4G, what they call it, long-term evolution. This is include your 5G as well. Is advanced LTE. And then as you can see here, the wireless, they are very on the down it's not very power efficient. Now you have a and then they're very very close to you, about 10 meters, 100 meters. The reason is that for wireless, when you transmit the wireless power going to be at least reciprocal of distance squared. That means it's going to be, the power going to be diminished as you go along. It's not like wired. Wired is going to be easy, right? So even you can have your power amplifier, in the middle because it's powered, right? So you can even, for you have a fiber optic for wired, you can send, 10 kilometer, 100 kilometer, even more than that, probably 1,000 kilometer if you have a power amplifier. So it's very easy. But for wireless, it's going to be difficult. First is that the signal is going to be down, reciprocal of the one, or the distance squared, or 1 over distance squared. So it's kind of diminished rapidly. And then on top of that, you have, if you are in tropical country like in Malaysia and Indonesia, we have hills, right? We have, in Indonesia, you have, Meru, whatever, Meru Hills, whatever you have in Indonesia, right? In Malaysia, we have Mount Kinabalu, for example, right? And so many, and you have a popular maybe Krakatau, is it? The Krakatau is a hill or mountain. So we have this, and then on top we have mountain. Oh yeah. So we have mountain and hill, and then we have what you call it? We have a tropical, trees, the foliage, going to obstruct the tree branch and the tree foliage, the leaf, they're going to, disturb all this wireless transmission because it's not wired, right? So the wireless will be disturbed. Okay. All right. Okay. Now, this is LP1 literature. If you want to do research on LP1, you're going to do a review of, of this, Internet of Things, industrial Internet of Things, machine-to-machine communication, industrial. So this is basically the umbrella of LP1 literature. It's become very popular now because I'm not sure whether you heard about the Industry 4.0. Industry 4.0 is basically the next industrial, revolution where people, rely more on the machine, on the technology and the intelligence. I think you heard from the previous, presentation, right, regarding the internet, artificial intelligence. So this is the Industry 4.0 where the industry they are moving towards intelligence now. So if you go to any car factory like for Toyota or Mercedes, if you haven't been one, I suggest you visit one. I think there's a lot of factories in Indonesia and similar in Malaysia as well. You can see a lot of robot, right? If you go to Japan, probably 80% they are automated robot, and if you go to Malaysia or Indonesia, they're probably about half than that, maybe 30%, 40% automated. But you can see many people working. And you go to Japan or to Germany, most of them they are a robot, the automation. So it's not only this. Robot automation is considered Industry 3.0. The 4.0, you have more than that. You have AI, data analytics, and so on, intelligence and autonomous and so on. So they are more than robotic automation. Okay. So all these things, the robot, in the Industry 4.0, they're going to be not going to be standalone. Most of them now they are standalone. After this, they're going to be connected, right? So the robot will talk to each other. They're going to, they will say, okay, I already finished. Instead of using a schedule, they probably don't have a schedule. They say, when I finish, then I will signal you. So the next robot, the second robot going to take over from the first robot. As of now, you need to have a specific schedule, right? 10 minutes for the first robot, 5 minutes to the second robot, and so on. But in the near future, maybe the robot will not, will not be, 10 minutes. If he can finish early, for example, right? Depend on the robot mode. Okay, maybe there is no such thing as robot mode. But anyway, in the AI, they probably have a mode, right? So so in this case, the robot will finish early, right? For maybe 3 minutes, and then instead of waiting for the next 10 minutes, for the next quantum, whatever, for the next period, they will go, they will, signal. So how they signal to the next one can be wired or wireless. So they use wireless. So LP1 or any wireless technology should do. If there are connected, you know, they're from remote, they're going to be they're going to use LP1. So as you can see here, the LP1 is become very popular lately. This is projection until 2023. From 2017, we are in 2021 now. As you can see, it's only 2 years, from now. As you can see, the increase, the probability of connection, wireless connection based on the IP1, or low power wireless area network, they are exponentially increased. Okay, so this is kind of, as you can see, most of them, they are about half of them, they're from LoRa, and then maybe SIG4 and NB-IoT and LTM is another popular one. So you have this, the popular one is SIG4, NB-IoT, and LTM. Actually, LTM is similar to NB-IoT. They use 4G or 5G connection, but NB-IoT is smaller power. LTM is a bit more high power. For example, if you want to send image, you probably don't use NB-IoT, you use LTM because it has more bandwidth here. Okay, what is the performance characteristic of LP1? So you have this energy and power efficiency, you have coverage, you have reliability, robustness, you have timeliness and scalability. So this is the very important, right? For example, energy and power efficiency, you probably, if you're doing some IoT, you probably have a power limit. You cannot go more than 1 watt or 1 milliwatt, depend on your regulator or authority, right? In Malaysia, we have MCMC. In US, they have FCC. I'm not sure in Indonesia what they call it. This authority,
Kominfo.
All right. So this
Kementerian Komunikasi dan Informasi.
Okay, this is they will kind of police, or they will go and control the spectrum and the power and everything. So it depends on this. So you cannot, for example, if you want to use ISM band, as you can see, most of this LP1 they use ISM band, stand for industrial, scientific, and medical. ISM band, like we use for Wi-Fi, right? So they have this power limitation. You cannot go more than that. And then for coverage, for example, RFID, whatever the coverage is, probably limited to 10 meters or 20 meters at most, or maybe proximity, right? So and for cellular, you can cover more, just like LP1, for example, right? So LP1, you obviously have to have more coverage, but the problem is that if you have wireless, then the power going to be diminished soon. If you have less power, then the power going to be diminished even earlier, right? Because you start with a very low power. So they're going to be an issue. And reliability and robustness. If you have a lot of tropical forest, hill, trees, and building between you and your recipient, between the transmitter and receiver, you're going to have a lot of this issue, right? Reliability and robustness, and obviously you can deploy a lot of coding, like in the previous presentation, there is a polar coding and also, but there is a limited, you can, if the thing is very bad, you cannot even error coding the thing is, even if you use the best one like Turbo or Polar, it's impossible, right, to recover, because it's just like macet, right? You cannot, if there is a macet, is traffic jam is very bad, you cannot even move, something like that, right? So it kind of in network similar. If you have a very huge delay, it become packet loss. You cannot even recover from that. It's kind of impossible. Depend on the situation, right? And then timeliness, and then this is kind of going to be a real time. Okay, believe or not, when I did my master, I think 20 years back, I have my friend who doing research on video. Video conferencing. This is what we talking now over the internet. At that time, it's very bad, So this is the delay is very bad. The bandwidth is huge. If you're connecting using your cell phone, the bandwidth is about kilobit per second, right? It's not even now. We have megabit per second. It's even better, right? Or maybe now with gigabit per second. Like my house, I have a 300 megabit, which is 1/3 of 1 gigabit per second. If I got money, maybe I can upgrade to 1 gigabit. So the bandwidth is good. The delay is less than 50 milliseconds, which is good. But 20 years back, it's not like this. Okay, it's going to be but for LP1, the timeliness is still very bad because it's a new technology and very bad. And we're going to improve on this. We're going to see it. And scalability, obviously, the scalability is actually, I'm not sure. Can you see this, or I need to hide this? Can you see the bottom? No, I need to hide this one.
Yeah.
No. Can you see there is there any like the blocking here? No. No, it's okay. All right.
You can see it. Yeah.
Yeah, you can see, but I cannot see it for some reason. Okay, I need to probably move this. There is a panel. Okay. Anyway, okay, you have a for scalability, capability of end device or base station is to cope with traffic requirement. If end device or no end device per base station, or no base station in the region, base station is what relay or the communication between the end user to the ISP, your company, right? Internet service provider. So then you're going to be if you want to put more, basically going to be increase of money. I think the reason the 5G going to be slow in most of the country, in Malaysia or in Indonesia, due to 5G, in order to scale, they need to add more, especially in the millimeter wave, because 5G they have normal microwave that we use now, and they have millimeter wave. For millimeter wave, they cannot go further, right? They need to put a lot of base station. But the company is not willing to, Telkom Indonesia, whatever, Telekom Malaysia, they're not willing to put this device in place, especially maybe in Jakarta, but for other places like if you go to, I'm not sure, if you go to Bukit Tinggi, whatever, right? So they have a lot of high hills there, that's why they name Bukit Tinggi, like Sumatra. Probably they're not going to pay this amount of money, because the return going to be less than their profit. So the government somehow need to, but I think that's why the 5G is going to be, if I being realistic, maybe within 5 years, even in Malaysia and Indonesia, they're not going to be rolled out, especially in the rural area. I'm going to go into that. All right, later. And then you have a cost. You have obviously you need to be, if it's very expensive, I think the previous presenter talking about satellite now. Actually, there are some solution based on the satellite was based by this Tesla company, SpaceX. They introduced the Starlink, but the Starlink, for wide area network, but it's going to be expensive. They're going to be very, very expensive, right? And then if you actually, the Starlink is quite new. They are only in US, but if you are in Malaysia, if you're rich, you can, or if you're Petronas, whatever big, in Indonesia, I'm not sure what is the company that handle the petrol in Indonesia, Petroleum Indonesia or something like that. In Malaysia, we have Petroleum National. Yeah. So they are rich. If they go to the sea, they can use this satellite phone. But if you are like me, we probably cannot afford this. It's going to be very expensive. You probably need to pay maybe, I don't know, 1 million for 1 year, right? I mean, for my house, I just pay about 100 ringgit or 200 ringgit for 1 year. If you are doing satellite phone, it probably costs 1 million 1 year, which is not practical for most of us, right? It's only for the kayangan. In Malaysia, we call the rich people is kayangan, right? So it's not for normal people like us, for the rest of the world. Okay, so you have this data rate and throughput, and you need to be, for your information, for LP1, this is going to be very difficult. We're trying to improve, our research trying to improve on data rate and throughput, but as far as LoRa is concerned, actually we tested LoRa in between an island, because we got some small grant from MCMC, from MTSB, one of the government. So we connect this island from Terengganu, about 20 kilometers, to one of the university, Terengganu University. I'm not sure about Terengganu, but Terengganu is in the east coast of West Malaysia. So Malaysia, we have two parts, right? We have we have west, which is we share with Indonesia, Kalimantan, and then we have the east, we have share with Kalimantan. We have West Malaysia. We call it Peninsula Malaysia or Semenanjung Malaysia. We have on the east coast of the West Malaysia, we have the Terengganu. So we have this research where we test the LoRa, and then you can send, believe it or not, you can send up to 20 kilometers, about 20 kilometers. It's very, very, very far. But you can send only few bytes, a few bits, basically several bits or bytes only, right? So you can send on off. You can turn on your for example, if you're doing your garden, you can turn on the valve by sending 1 and 0, right? But that's all. You cannot even, send an image, because image is probably more than bytes. So it's going to be very slow and not real time. Okay, and then you have this mobility. as of now, most of the LP1 they don't support mobility. Maybe in the near future we're going to have this mobility and flexibility and obviously security and openness. Okay, I have one student who's working on this security and openness, but the issue is not is that can you have a security when you're offline, right? So for example, if your car, you open your car using your phone, right? And then what happens if your phone is out of the range? If you go to, in Malaysia now is, before the COVID, is a very popular trend to bring your family to camping site. Some they call it proper, some they call camping, and some of them they go to glamping. Glamping is for glamour camping. That's an expensive one. But normally other normal people they go for normal camping where you bring your family to away from your house, and then go to the beach or go to the hill or mountain, whatever, Taman Negara, whatever, right? National park. So, but over there there's no internet. So how can you start your car if your car is start by your phone? So it's going to be difficult. So we doing some work on security as well, on how to start the car if you are not connected to the base station, to the internet. But anyway, that's one of the thing that we're going to solve. All right. So
sorry, Professor. Maybe another 10 minutes.
Okay. All right. Sure. Yeah.
Thank you.
Okay. Now the next one. Oh no, I need to move. Cannot see this. Okay. If you can see, this is the what you call it, the comparison between the what you call it, the characteristic and the operating frequency, transmitted power, the parameters like propagation, environment, different modulation, diversity, coding, multiple access, topology, network activity, device composition, data rate. So as you can see here, there is a mapping between between these the relevant characteristic and the parameter that you want to provide, right? Okay. Okay. So the next one, you have 4 existing popular LTE1. We have a LoRa, Sigfox, MBOT, LTM. As you can see from the adoption graph, you can see that LoRa and MBOT, they are because LoRa is not based on cellular. It use ISM band, free band, and then MBOT use cellular based, and then it doesn't use SM band. It use commercial bands. For example, like Telkom Indonesia or Telekom Malaysia, or or Celcom, for example, this commercial ISP, they probably provide this MBOT, through their 3G or 4G network. But Telekom Malaysia, as well, they now they're starting to provide LoRa as well. But this is over the what we call it, sub gigahertz. Okay, because LoRa you need to have if you understand wireless, when you go low frequency, you can go further, right? So this is the reason they use sub gigahertz, less than 1 gigahertz. So and then they use this unlicensed band as well. So for example, if the Petronas want to use LoRa, they probably contact Telekom Malaysia or Celcom, for example, or I want to use LoRa instead of MBOT. Then they provide them with sub gigahertz a network. For MBOT, normally they use these 2 gigahertz or 3 gigahertz network, cellular based network. So this is the difference between LoRa, Sigfox, and MBOT LTM. So these first two, they are based on ISM band, and then the MBOT LTM, they based on commercial frequency band for what you call it, cellular network. All right. Right. Okay. LoRa or LoRaWAN, they're based on chip spectrum. Okay. This is a wireless technology where you have this, the signal kind of, the user of the signal, they send in the spectrum technique, where they are orthogonal to each other in a way that in the way that they coded it, in the way that they don't interfere with with each other. So in LoRa, they have this what they call it as SF, spreading factor. You have, for example, here you have from 7 until 12. You can go higher bandwidth with 7, but you have a least bandwidth to 12. But if you go to 7, the bandwidth is increased, but the distance is considerably reduced. Okay, for example, when we do the connection between this island, right? I remember this island of the coast of Terengganu to this one of the University Malaysia Terengganu, about 20 kilometers. We have to use the 12 spreading factor because the distance is very far. This is point to point. Is a line of sight point to point. Nothing in between. Right? So it can achieve 20 kilometers, which is impressive, right? But again, it's kind of very low power, and then because of this spreading factor 12, you can send a simple bit, like 1 byte or few byte, like to turn on to off your valve or your sprinkler for the water, right? For the gardening, it's nothing more than that. You can even send image or video, right? Right, and the Sigfox, they use this time division multiple access, FTDMA. If you know communication or networking, you can divide the channel by frequency or time domain. That's a very popular one, right? So the time and frequency domain in this is a time domain. This is Sigfox. This is a commercial. Sigfox is all commercial. For LoRa, the physical is commercial. The LoRa one is the layer 2. If you learn networking, you have layer 1, 2, 3 until 5. For TCP/IP or 7, if you use what you call it, OSI. But for layer 2 and until 5, until application layer, for TCP/IP, for example, LoRa one is layer 2 is open, right? For Sigfox, they are closed. Most of them they are closed. Right, and then you have this MBIoT. MBIoT is I think is a standard based on CGPP or this TGP consortium. Okay, this is cellular. They use simplification of LTE for IT application, single antenna. All right, and then they have this BPSK and QPSK modulation, and then they have a single carrier FDMA. They didn't use multi-carrier. If you use Wi-Fi, they use multi-carrier. The reason they use single carrier because your power amplifier is going to be lower power, right? There's no nonlinear distortion and everything, right? So you have this single carrier for uplink and downlink. And then the bandwidth is a bit low, about 200 kilohertz. So you can get about kilobyte here. If you have a symbol 4 times, maybe you can have about, I'm not sure whether you can have 1 meg, probably pushing it, right? Okay, and then yeah, actually there is a new standard from I've been to IIT Madras, and then India actually proposing. I'm not sure. I think they already accepted. They based on new modulation. They call it DPPSK, okay, the differential BPSK, because India, because most of this standard, believe it or not, they make by the European company, European entity. They don't really have what you call it, trees like tropical, hilly. They have a very nice, line of sight. So that's why India, they have more rugged terrain like us. Probably not as bad as us, but they propose DPPSK. It's one of the 4G standard. All right, or 5G standard. Yeah. Okay, and then you have LTM. This is a complement and cohesive NB-IoT. This is for higher bandwidth, higher performance. Use the same CFDMA. And then you can, probably send more data like image or probably a video because it's 16 QoM. But it kind of, higher power due to this modulation, higher, complexity modulation. Okay, these are 2 upcoming ones. We just go through this quickly. MyIoT and RPW. This is very new. They are probably not in the market yet. And RPW, MyIoT stand for, I think, just massive IoT, something like that. This is the name of the standard. And then RPW stand for rotating polarization wave. RPW, this is what we focus on. Okay, basically this MyIoT is a new technology. They're based on telegram splitting multiple access, similar to spread spectrum. It's an AC standard, and then it's not very high bandwidth, about 2 kilohertz, and 1 message per 1 radio station. Okay. So I'm going to talk more about RPW. I hope I still got time. Actually, RPW is what we're working on. One of my PhD student working on this thing. And if anybody, one of the student, master student here want to, or undergraduate student want to continue, study in Malaysia, you're welcome. I think there's some scholarship, available, right? So you can come to Malaysia or UPM to do this further research, okay, on wireless. So the RPW actually invented by Hitachi Research Laboratory Japan, and then it's using multi-level rotating projection.
Sorry, Professor, your slide is not moving. Your slide is in NBIoT.
Okay.
You already changed your slide, right?
Yeah, already changed. Yeah. Can you see? No. Can I?
What page now? 16. Oh,
RPW.
okay.
RPW.
Okay. We can see that.
Can you see it? Okay.
Yeah.
RPW.
Okay.
All right. I think maybe something is maybe I touched it by mistake. Sorry about that. So now you have this RPW is invented in Hitachi. Actually, we have agreement kind of MOA, with Hitachi Research Laboratory Japan on extending this technology. All right. As you can see here, you can see that this is in wireless. You can if you want to encode the information, you can change using your your phase and amplitude, right? If you know wireless communication, you use your amplitude or your phase. Okay, but there is unique for electromagnetic wave. You have polarization as well for sound wave. If you're detecting the earthquake, like Indonesia, I have another research for detecting earthquake, right? I have with Philippines. Somehow I cannot get collaborator from Indonesia maybe later, right? But anyway, for earthquake, you have this when you detect sound wave, so they have only amplitude and phase. But for electromagnetic wave, like we use for communication, EM wave, we call it, they have a polarization. So in most of the system, they based on amplitude and phase. But this Hitachi, they propose using polarization, okay? And they kind of make it suitable for communication. We kind of extend the bandwidth, if you like, on this communication. That one of my student work, we managed to increase the bandwidth from kilohertz, from just a few kilohertz to kilobit bandwidth to 10 or 100 kilobit bandwidth. All right. So this is what you call it, the comparison between the existing one and upcoming one. As you can see, LoRa SIG4 MBOT LTM, they are both, mainly using unlicensed and licensed for MBOT LTM. And for the upcoming one, we use this sub-gigahertz, normally ISM unlicensed band. And then, as you can see, this LoRa is proprietary and LoRa one is standard. For proprietary and MBOT, obviously, is a 3GPP standard. And physical layer, you have spectrum, frequency hopping for SIG4, something like spectrum. And then you have this, single carrier FDMA. This is similar to your Wi-Fi modulation, but they focus on a single carrier for less distortion. And we have MOT and RPW based on the frequency hopping and polarization. Okay, for RPW. And as you can see, the modulation, they use this CSS for LoRa, DPPSK for SIG4. This is similar to proposed by the Indian government to the 3GPP, but existing 3GPP, they don't use DPPSK. Maybe soon they're going to use it because you're standardized. They use DPPSK and QPSK, and for the higher one, LP1 based on LTM, they use QAM. For upcoming RP1, we use RPM based. Actually, we already increased it to higher complexity using this, RP and MPSK, because QM is going to be difficult for RP1. I think this is the what you call it, the advantage, major limitation, and resistance strength. As you can see, the minority and LP1, they're not that significant work, and then LP1 we just trying to be investigated. Hopefully, we already finish the simulation, and hopefully we can perform the implementation inside inside the hardware now. Now we just use this simulation and MATLAB. Hopefully, actually the first PW by Hitachi already have an implementation. I'm talking about the high bandwidth that we propose still in simulation. Hopefully, we're going to put them into the hardware. And last but not least is the future direction. As I mentioned to you, you have this, phase, amplitude, and polarization. Right? Actually, there is another one. If you heard about this massive MIMO antenna, space diversity. Actually, you can do some extra another dimension of wireless encoding based on the space. And you probably can propose this. For example, like orthogonal time frequency space modulation. I think this is proposed by Stanford UC US. I'm not sure how it go, but they're still in the beginning. So this is on top of your normal RTM Wi-Fi modulation, and then obviously there's some potential orthogonal time synchronization. So hopefully they can improve the timeliness, the delay jitter, delay variation, and so on, and to improve the reliability and robustness. Okay, I forgot to mention the point that actually the RPW, actually the first generation, Hitachi already test inside the bunker, the nuclear bunker, because in Japan they have this nuclear facility. If you heard about this Fukushima, right, the incident, actually they have many in Japan. Fukushima is one of them, right, the catastrophe. The old, actually Fukushima is the old design one. That's why they got problem. You heard about this, right? But they have other nuclear, that this after the first generation, they already implemented it. They can go through bunkers, all right? So we hopefully sooner or later we're going to test it on the tropical forest, okay? And so actually we joined I think ICITAMEE connected the unconnected. They call it CTU challenge. I think you go to the ICITAMEE, the future network chapter. Now they have this competition of connecting the unconnected. So basically we have this problem where the rural area, as I mentioned, in the Bukit Tinggi area in Malaysia, they have a Sabah area or Sarawak area. In Kalimantan area, they are very hilly. And tropical is very difficult to reach. So hopefully using this upgrade view, they can overcome this hill, none or near line of sight, limitation, through the trees, through the branch, to the hill, so that you can have connected to connect more people in the rural area, especially, right? So this is one of the motivation. Probably I forgot to mention it. Okay, I think maybe future they're going to have hybrid IP1 rather than one solution. And then as I mentioned, the hardware need to be suitable for the users, and then the implementation hopefully going to follow in the near future, inshallah. And then other than that, you can have a resource allocation and multimedia support. Probably it's not a good idea to send bandwidth, high bandwidth video over the LoRa or LP1 or NB-IoT at the moment. Maybe LTM, but not NB-IoT, because the bandwidth is not there. But you never know. As I mentioned to you, 20 years ago, nobody fully, use video conferencing, reliably over the internet. But now it's normal, right? Maybe in the near future, if there's a new standard protocol coming up, whether based on RPFU or based on something else, hopefully LP1 can support multimedia. You can even have a very low power over the long distance to transmit your videos. So I think that's going to be the what you call it, the aim that we trying to achieve. So for example, you can connect all the island, right? For the island, better to use the wireless, because wire going to be very expensive. And especially in Indonesia, you have many islands, right? So it's going to be good for, I think, small islands to be connected to the main, island. I think that's all. This is a biography of our, presentation. And as you can see, this is our existing, what you call it, publication. This is our latest publication within this year or last year, and then inshallah we're going to publish another one, a comparison with LoRa, that's upcoming hopefully this year, inshallah. I think that's all for today. I hope I'm not beyond time, too much time. Sorry, Mr. Chairman. I hope it's still within time. Thanks. Perhaps we can go to question and answer now. Thank you.
Yeah. Thank you so much. Thank you, Professor Saiful, for your very interesting and nice presentation. I think we go directly for question and answer session for the second for this session. Please, for participant, if you have anything to ask to Professor Saiful,
I have this question
ask directly.
by Fidaus. Can please?
Sorry?
Many papers wrote that LoRa has a great
Ah.
potential for implementation in space to Earth satellite communication. What is your opinion about that?
Oh, okay. Yes.
Yes,
Yes.
correct. Yeah. Actually, actually, one of my colleagues, when I did my when I did my PhD in Cardiff, my colleague, one of them actually in his spare time he kind of make the circuit, because LoRa you can buy the chip from microchip or or any other, and then you can make your own. Actually, he make one for I think for kind of a balloon, right? Balloon, right? You can go up to many kilometers, right? But balloon, so you can put the weather balloon, whatever, right? You can put it inside that thing, and LoRa is very good at this, especially from like you mentioned, the space to Earth, because LoRa, as I mentioned, for line of sight, LoRa and even RPW, are going to be perform similarly, to the because it just use spectrum. To be honest with you, the GPS use spectrum technique as well, right? So it's going to be not very very the advantage is going to be the low power. For example, if you have for a low power satellite, right? Normally most of the satellite, they are very high power. If you have a low power satellite, if you have a balloon, very high altitude balloon, you need to have high power, right? If you solar, then we're going to be good. Because to be honest with you, for line of sight, LoRa and RPW is going to be not much different. But for terrestrial, what I mean by terrestrial, between from Earth to Earth, not Earth to satellite, the LoRa will suffer. So this is what from our research, the LoRa will suffer. But it's very popular now. But I think sooner or later, I think people will have this limitation, because if they want to go for more reliability, higher bandwidth and so on, LoRa will I think unless they kind of improve the thing. Now they're improving it using some equalizer. I think the latest research on LoRa. I'm not sure. Is there anyone here working on LoRa? So they introduce some equalizer, some kind of coding or encoding, perhaps, right? So yeah. But based on our simulation for terrestrial, I'm biased because we are doing research on RPD1 against LoRa. I think actually RPD1 is much better than LoRa, at least on paper. So kind of yeah. Hopefully hopefully in the next month also, we're going to publish this paper, and we can check the LoRa again. But as you rightly pointed out, that from Earth to satellite, because there's a line of sight, because between Earth and satellite there is no mountain in between, right? If you just look at the sky, you can see the satellite, right? For the Starlink, as mentioned, SpaceX, sometimes you can see the Starlink satellite, but the Starlink is a low Earth satellite. There are two types of satellite. You have a geo satellite, very like 40 kilometer, whatever, right? 3,000 kilometer above, and you have this low Earth satellite like Starlink, right? They are quite they're quite much lower than the geo satellite. I think LoRa can be good, but again, I think any spectrum will be good. That doesn't have to be LoRa. The advantage of using LoRa is just if you want low power. But I don't think the Starlink, the solution is going to be very expensive. Obviously, they're not using LoRa as far as concerned. They probably use some sort of spectrum, because I think spectrum is kind of very good for long distance, especially, right? And line of sight. It must be long distance and line of sight. If not line of sight, then they're going to be to struggle. Okay, or near line of sight, going to struggle, especially if we have a like for terrestrial, we have jungle, forest. We have the Malaysia and Indonesia. We share this. Kalimantan is the oldest. I'm not sure you know this. Is the oldest rainforest in the world. Actually, is the oldest forest in the world. So it's a few million years. So it's kind of very thick and canopy leaf and everything, which is kind of impossible to Actually, we try with LoRa. To be honest with you, you cannot even make a connection even a few meter, because we have island. You just imagine, we have an island to the mainland, 20 kilometer. We can connect using LoRa, right? But if we have a node about less than 1 kilometer, maybe 100 meters or something like that, maybe less than that, to the base station, we cannot even connect using LoRa. It's how bad is that solution? Because it is made by European. They don't make it for Asian our environment. I think that's hopefully other solution will be, or maybe LoRa improve on the equalization and coding, everything maybe they will be improved. But as of now, they are not that good in terms of terrestrial. Like you suggest for satellite, I think it's okay. That's right. Yeah.
Thank you, Professor, for your answer. And yeah, there is another question from Rizal. In your opinion, what form of collaboration is important between Indonesia and Malaysia that can accelerate the growth of digital technology literacy? Any comment?
I cannot read it. Where is it? Somebody writing?
From.
Can you write inside the message? Maybe I cannot see. Can I see the message?
Yeah, this in the message.
Okay.
Just,
all right.
Yeah.
Sure. I'm looking at the direct message. Okay, I'm looking at the all message now. Sorry. Direct message. Where is it? Is it the chat, right? Oh, no, I don't.
Yeah, chat. Just before the Google form link.
Google form link. I cannot.
Just before that.
Can somebody paste the direct message to me? Somehow I cannot find the. Can Chairman
sure.
paste a better?
Okay, sure.
Okay, in your opinion, what form of collaboration is important between Indonesia and Malaysia can accelerate the growth of digital technology literacy? I'm not sure about the question. Correct me if I'm wrong. The question is nothing to do with my presentation, right? This is more on digital technology literacy because my presentation on wireless technology. But if you want, I can answer, but it's not relevant to our, maybe directly relevant to the.
Maybe you can just comment, short comment.
Oh, just comment. Okay. Maybe I hope I don't make a wrong, comment. But anyway, what collaboration between Indonesia and Malaysia that can accelerate the growth of digital technology? I think as I mentioned before, it's kind of maybe relevant to our presentation. I think the rural area need to be, need to be connected first. It's an enabler, right? You give them there is a popular saying that if you give men a fish, you can feed him for a day. If you give him a rod, a fishing rod, they can feed him into in the lifetime. You understand that? I hope in Malay or whatever Indonesian language, kalau bagi ikan boleh makan sehari, tapi kalau bagi pancing boleh pancing selama-lamanya kan. So that's that's the meaning. I hope everybody understand this. So the tools, the rural wireless technology and other, actually it's just enabler. Right? It's a tool for people to learn. Because now internet is the largest library. Right? I'm not sure, Mr. Chairman, when you was young, you have to go to the library and search. When I was young, when I was your the undergraduate, I had to go to the libraries, and to bookstore and the internet is not that as of now. Now I just go to Google Scholar. I think most of you do some research. You just go to Google or Google Scholar, and then you can just get the link for the for the paper, right? If your university subscribe to the paper, then you can get the paper. Or if you're not subscribed to the paper, maybe you can go to this is not recommended, but you can go to this pirate site, whatever, right, to get the paper. But my point is that the paper is available, right? So but before you have this, you need to have this the infrastructure. I think that's why I think the 5G is going to be kind of for Malaysian and even Indonesian government, the 5G is going to be kind of a catch-22 situation. I'm not sure whether you understand the meaning of catch-22 situation. Catch-22 meaning that either it's chicken or egg first. Some people say, is it a chicken first or egg first? it's going to be like that, because the company, they cannot spend the money. For example, like say if the Telecom Indonesia or want to to put their towers in a remote area, like in a Bukit Tinggi somewhere in in the middle of nowhere, for example, right? That probably is not as good for them as a Jakarta. So we're going to pay for this. The government need to pay for this, right? Or maybe subsidize this, or maybe. So this is the dilemma. The same with Malaysia. It's nothing to do with Indonesian government. I think all the government have a similar dilemma. How to how to encourage the encourage the company to contribute to the society, to connect the rural area and so on. So one of our work on RPW, actually this is our work, try to try to make it accessible by the technology and probably make it more cheaper than the current 5G so I'm not sure even in US they have this rural problem, not even in Malaysia and Indonesia, they have this rural problem, and then the US just granted 10 billion. I'm not making this up, you can check on the internet, about 10 billion, at least 10 billion USD, not that, about 40 billion Malaysia ringgit. I'm not sure how many billion or trillion in rupiah, but it's a huge sum of money, right? So they give it to SpaceX to make this available, not around the world, just available for the US citizen, for the rural, using this Starlink satellite connection for the rural area. So if you are in Arizona, in the middle of the ranch, ranch, the cowboy ranch, you have this, because in Arizona, especially, you have this a lot of like a semi-desert. The connection is not very good, actually quite bad, for example, right? And then you can use this satellite, and then you can now is a pandemic, right? You don't work, you work from home. So now, instead of you buy the house in San Francisco, it's going to be very, very expensive. Just buy a house with the same amount of money. You can not buy a house, you can buy a ranch. You can buy 1,000 hectares instead of one room in San Francisco. And then you can work from Arizona if the connection is good. So as if you are, you don't need to go to, you can go probably once a month or once a year to your headquarters in San Francisco, in Silicon Valley, right? So this is the idea. That's why even I think the government, they need to invest in this area, so that the digital literacy is going to be much better in Malaysia, Indonesia, even all over the world, because the internet is where the knowledge are now. I myself have a lot of books in my library. Maybe I can show you my library inside my room now, but still is a minuscule. It's very small compared to what we have inside. Even some of my most of my book now is online. Ebook I bought from online, right? Most of the book not in the shelf, in the virtual shelf. So I need to have connection to the internet to access my book, or some of them I download inside mine, but not all of them. I still need connection if I want to download some of the book, and some of them paper are not available to me. They subscribe to my university. So like ICITAMEE, like Explore and database, right? So this kind of thing. But you need to have an internet connection to have digital literacy. I'm sorry if I'm not answering your question directly, but I think I'm trying to answer in relation to what I present today. All right, thank you.
Okay, thank you very much.
Yeah.
Thank you very much, Professor.
Yeah.
Still have question maybe from other?
Yeah, I got this direct message that
Yes.
Can you share presentation file? I think I already sent the presentation file, right? I think the chairman maybe can share. Okay.
Maybe we can share later on.
Yeah,
okay.
yeah. All right.
Okay.
Yeah. And then I have message from personal message from Firdaus. I think maybe this is a personal message about UTM. But anyway, maybe it's not a question. But anyway, any more question regarding the presentation, or maybe related to the presentation? If I can answer the thing. Before I finish, I think this is going to be very interesting. The Internet of Things and the COVID, and I think this is where the communication, especially, right, computer communication, play their role in kind of connecting the people, right? So yeah, I think that I think is very important. Where if you have this infrastructure and the facility, people can work together regardless of their place. Okay, for example, 20 years ago, maybe 50 years ago, if you are living in the village, you cannot access to the best professor, whatever, to the best books in the world, right? Because you are very far from the city, from the Jakarta, from Bandung, right? You have to go from other place, right? Other island, just to go to the city to learn, right? So that happened to most of us. But maybe now you don't need to leave your village. You can just stay in your village and do whatever you do, and then still be educated and still be I think this is going to be some paradigm shift, partly due to COVID as well, and partly due to the trend like Industry 4.0 and so on. Okay, I think that's all. If there is no more questions.
Thank you. Thank you so much for Professor Saiful for your presentation and answering some of the questions from participants. Due to the time limitation, so we have to end this second session with you. I'm sorry, but maybe later on we can invite you in another event, and we give you more time for presentation and discussion.
Thanks for the invitation. I hope
we also thank you very much for your attendance. Thank you so much for your sharing and give us some new knowledge, new insight, very insightful, and also success for your project and your current research in Malaysia. Hopefully, maybe related to some project that are similar with Indonesian situation, like what you call the earthquake or something. Yeah, I think if possible, I think if possible, then we can talk further for that.
Actually, I sent email to a few Indonesian researchers. I think maybe you got the email as well, right? To invite for earthquake, but maybe you're not directly in the field. But actually, I sent to some of the Bandung, professor ITB, but they don't reply. I'm not sure. Maybe the email was wrong. I'm not sure regarding the collaboration. Maybe later, we can further
many things.
collaborate.
Actually, we can implement the LoRa or RPW.
All right. Okay.
In the forest.
Maybe
so much.
in the near future, inshallah, I can go to to your place, to your university for exchange, or for the conference.
Sure.
You can come here.
Very welcome.
All right.
Very welcome, Professor. Thank you very much. Terima kasih
Bye.
banyak, Professor Saiful, for your sharing. Waalaikumsalam. So by the end of the second session, so we are finished the presentation and question answer session for the first presenter, was keynote speaker Professor Khairul Anwar, and the second speaker Professor Saiful from University Putra Malaysia. So this is the end of this webinar pre-conference with two keynote speakers. Thank you so much once again for the keynote speakers that already share your expertise to us, to all of us here. Then hopefully it can be our new insight and new knowledge, and we can implement and trigger us to implement in our field, whether in electrical engineering or in another domain, maybe. For example, to solve the pandemic situation like this, maybe based on our discussion, it can trigger your new idea for that. For all participants, thank you very much, and thank you so much for all of participants that already give response, comment, and question in these two sessions. And I will give back to the MC for closing this event, please.
Okay, thank you, Mr. Widyasmoro, ST and SC, for the moderator task. Ladies and gentlemen, finally we arrive at the end of the webinar. For documentation purpose, we will take some pictures for latest one. Please open your camera and I will count to 3. One, two, three. Okay, thank you. Next, we will send by email for the webinar certificate. So please fill the attendance form, and for ICITAMEE participants, the program book will be sent by email today, inshallah. Then, thank you for all your participation in this webinar today, and see you in the conference day at 25 and 26 August 2021. Allow me to conclude this webinar ceremony by reciting Hamdalah together. Alhamdulillahirabbil alamin. Wassalamualaikum warahmatullahi wabarakatuh. Have a great day.
Waalaikumsalam. Thank you, Prof. Assalamualaikum.
Waalaikumsalam warahmatullah. Thank you, Bu Jesse.
Prof. Khairul.
Pak
Ya,
Daniel.
Pak.
Ya.
Pak Khairul.
Izin pamit.
Thank you so much.
Ya.
Prof. Saiful, terima kasih. Prof. Khairul, terima kasih.
Sama-sama, Pak. Terima kasih.
Ya. Thank you, Profesor.
Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Keblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah, atas berkat rahmat Allah Subhanahu wa Ta'ala dan didukung usaha keras dari seluruh sivitas akademika Teknik Elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi Teknik Elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen-dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari laboratorium telekomunikasi, laboratorium rangkaian listrik, laboratorium digital dan mikroprosesor, laboratorium elektronika, laboratorium instrumentasi dan kendali, serta laboratorium komputasi dan perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah, atas berkat rahmat Allah Subhanahu wa Ta'ala dan didukung usaha keras dari seluruh sivitas akademika Teknik Elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi Teknik Elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen-dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari laboratorium telekomunikasi, laboratorium rangkaian listrik, laboratorium digital dan mikroprosesor, laboratorium elektronika, laboratorium instrumentasi dan kendali, serta laboratorium komputasi dan perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Through education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah atas berkat rahmat Allah Subhanahu wa taala dan didukung usaha keras dari seluruh sivitas akademika Teknik Elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi Teknik Elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen-dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari Laboratorium Telekomunikasi, Laboratorium Rangkaian Listrik, Laboratorium Digital dan Mikroprosesor, Laboratorium Elektronika, Laboratorium Instrumentasi dan Kendali, serta Laboratorium Komputasi dan Perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. culture of education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process. We will always create technology that is oriented toward the benefit of the people, to improve the people's welfare and create the developed society. The Faculty of Engineering, Universitas Muhammadiyah Yogyakarta.
Daerah Istimewa Yogyakarta merupakan sebuah provinsi di Pulau Jawa yang terkenal akan kekayaan budaya dan pariwisatanya. Pelajar dari berbagai penjuru negeri, bahkan internasional, memilih Yogyakarta sebagai tempat menempuh pendidikan. Salah satu perguruan tinggi swasta terbesar di Yogyakarta adalah Universitas Muhammadiyah Yogyakarta. Kampus yang berdiri pada tanggal 1 Maret 1981 ini berlokasi di Jalan Brawijaya, Geblakan, Taman Tirto, Kecamatan Kasihan, Bantul, Daerah Istimewa Yogyakarta. UMY telah mendapatkan akreditasi dengan peringkat A berdasarkan surat keputusan dari Badan Akreditasi Nasional Perguruan Tinggi. UMY juga telah mendapatkan akreditasi tingkat internasional dari QS Stars dengan perolehan bintang 5 untuk bidang fasilitas, bintang 5 untuk bidang pengajaran, dan bintang 5 untuk bidang daya serap lulusan. UMY memiliki 9 fakultas dan lebih dari 30 program studi yang terpadu dalam area seluas 32 hektar. Universitas Muhammadiyah Yogyakarta terus berusaha untuk mencapai tujuannya, yaitu terwujudnya sarjana yang beriman, bertakwa, dan berakhlak mulia, yang mampu mengamalkan dan mengembangkan ilmu pengetahuan dan teknologi, serta berguna bagi umat, bangsa, dan kemanusiaan. Teknik Elektro merupakan salah satu program studi unggulan yang terdapat di Universitas Muhammadiyah Yogyakarta.
Visi kami adalah menjadi program studi teknik elektro yang unggul dalam inovasi bidang sistem tenaga listrik, didukung teknologi cerdas di tingkat nasional dan diakui di tingkat internasional pada tahun 2025 berlandaskan nilai-nilai Islam untuk kemaslahatan umat. Pada saat ini, alhamdulillah, atas berkat rahmat Allah Subhanahu wa Ta'ala dan didukung usaha keras dari seluruh sivitas akademika teknik elektro UMY, kini Prodi Teknik Elektro UMY telah terakreditasi A dari Badan Akreditasi Nasional Perguruan Tinggi. Konsentrasi program studi teknik elektro UMY adalah yang pertama yaitu sistem tenaga listrik, yang kedua adalah sistem telekomunikasi, yang ketiga adalah sistem kontrol dan instrumentasi, yang keempat adalah sistem elektronika, dan yang kelima adalah sistem komputer dan informatika. Kemudian kualifikasi dari dosen-dosen teknik elektro UMY, alhamdulillah dosen teknik elektro UMY merupakan lulusan-lulusan yang qualified, yang berasal dari perguruan tinggi yang ternama baik di dalam negeri maupun yang berasal dari luar negeri, di mana kualifikasi pendidikannya adalah minimal S2 dan mayoritas saat ini telah berpendidikan S3.
Selain sumber daya tenaga pengajar yang berkualitas, Teknik Elektro UMY juga menyediakan berbagai fasilitas yang mampu menunjang pengembangan diri para mahasiswanya, seperti laboratorium. Laboratorium yang terdapat di Teknik Elektro UMY terdiri dari Laboratorium Telekomunikasi, Laboratorium Rangkaian Listrik, Laboratorium Digital dan Mikroprosesor, Laboratorium Elektronika, Laboratorium Instrumentasi dan Kendali, serta Laboratorium Komputasi dan Perancangan. Mahasiswa Teknik Elektro UMY juga telah mengukir banyak prestasi baik di tingkat regional, nasional, dan internasional.
Universitas Muhammadiyah Yogyakarta, Young and Global. Welcome to the Faculty of Engineering. We are part of the Muhammadiyah Development Center and play a role in the engineering field. Currently, we are developing technology and global-oriented innovation through developing cooperation to an international level based on Islamic values for the benefit of the people. Ministry of Education, we develop students to become excellent and Islamic graduate, and we do research and community service professionally. We are also a medium for students to develop an entrepreneurial spirit. Have adequate facility and professional teaching staff to support the lecture process.